Okay, everyone, nose out, please. Computer down, please. No mobile phones, no laptops. Okay, so let's continue with example 2. That's what I asked you to try last lesson. In a survey of 100 university students, a market research company found that 70 students own smartphone and 45 own cars, and 35 own smartphone and cars. Use Venn diagram to help you answer the following question. Okay, we need to put a Venn diagram first. Okay, yesterday I just see some of you forget this rectangle outside. Okay, the two circles cannot make the entire set because this two circles only talk about the situation that student owns something, but there possibly be someone hasn't owned anything, not the car, not the smartphone. That's outside the two circles in the rectangle. Okay, so we have smartphone and we have car. Not most of the time we start from inside, okay, the intersection part. So 35 on both. So I will have 35 in the circle first. And then we have 70 on smartphone. So we have another 35 here because entire circle should give you 70. Okay, so 35 already, the rest must be 35. And then 45 on cars, and then 35 already, then 10 for the rest. Okay, so how many students we investigate in total is 100. Okay, so 70 plus 10 is 80. There's a 20 outside. That number must be there. Okay, that is the A dash intersects B dash part, which is who has not got the phone nor a smart or the car. Okay, so if you don't write the 20, you lose 1 mark directly. Okay, the 20 is important, which makes entire set. So for this entire set, you have 4 elements. Okay, normally for 2 circles, you have 4 elements. Intersections A only, B only, and not A, not B. Okay, not A, not B. So we have this here first, and then we have look at the questions. How many students own neither a car nor a smartphone? So that is A, what is asking. How many? It's not asking you a probability. It's just asking you how many are there. This 20. Okay, 20 of them. If I can use a set notation, I can say number of A dash and S dash intersect C dash. That equals to 20. Number of elements in that set. What set? Not S, not A, not C. Okay, not S, not C. So it's 20. Okay, for B, how many students own either a car or a smartphone, but not both? Okay, not both. It's hard to use a set notation to represent that, so we can directly answer that. It's just a 35 plus the 10. That is a 45. Okay, we have 45 of them, not both, but all one of that. All right. Okay, number 3 is interesting. Number 3 asks you to use the Canon map, the probability table, to work on this question. So at the barbecue attended by 50 people, hamburgers and sausages were available. It was found 35 hamburgers and 38 sausages were eaten in total, and 6 people were not to have eaten neither a hamburger nor a sausage. So 6 people eating nothing. If no person ate more than 1 hamburger or 1 sausages, find the probability for the following. Okay, first of all, this sentence is very important. If no person ate more than 1 hamburger nor 1 sausages, which means the maximum number of sausages can be consumed is 50. And maximum number of hamburgers could be consumed is 50 as well. If they can eat more than 1, then it's not 50 anymore. It will be like 100 or 200, it doesn't matter. So then I can use this table. Okay, this table is a 4 times 4 table. Okay, this table is a 4 times 4 table. So I can write like there's 2 events, either they eat hamburger or not eat hamburger. They eat sausage or they not eat sausage. We can complete the corner one first because that will be a 50. Okay, the total number of people is 50. They can't consume more than 50 of one thing, so that's a 50. And it was available. We found 35 hamburgers were eaten, so 35 must be here, and 38 must be here. This, okay, opposite to hamburger, that's the total number of hamburgers could be consumed. This is sausage, that's the total number of sausage could be consumed in the last box. And the middle 4 is the intersection. Okay, the middle 4 is the intersection. Okay, so what we have, 6 people will not eat a hamburger nor a sausage, is S dash intersects H dash. Against the outside bit, nothing. So I have 6 here. I can use that to calculate all the rest of the number because they add horizontally and they add vertically is all true. So I will use a black pen to write next layer. 35 add what can give you a 50? Add a 15 can give you a 50. 38 add 12 can give you a 50. So that must be 15 and 12. Okay, by giving you the black one, then you can keep going. Let's use a green one. 12 minus 6, I have a 6. 15 minus a 6, I get a 9. After I complete the green one, okay, this column and this row can give me the first number here now, which is a 29. Which is a 29. After I complete the table, I need to check. Okay, add horizontally, 29 times plus 9 is a 38. 6 plus 6 is a 12, 35, 15 is a 50. Oh, good. 29, 6, 35, 9, 6, 15, 38, 12, 50. Okay, it's a good table. Okay, everything is correct, and I put all the information in. Now I will, okay, what 29 represent? 29 is the people who eat hamburger and sausage. Okay, eat one hamburger and one sausage. Okay, what here represent? Here is people who only have sausage but not hamburger. This one is people who has hamburger but not sausage. Okay, this one is not sausage, not hamburger. Okay, so that 4 give you like the relationship between them. So A is asking a hamburger or a sausage. Well, like A and C is a little bit confusing, like the language here is not very good. So A is actually asking the probability of okay. A is actually asking, okay, C is only 1/3 of one food. So A is asking if the people eat a hamburger or eat a sausage or both is fine. So it's the or relationship. Can you see the or? The or means union. The or means union. Hamburger or sausage means hamburger union sausages. So it's the probability of hamburger union sausage. Okay, what that probability will be? So that will be the probability 1 minus the probability of H dash intersects S dash. They eat at least something. Is the total subtract the eaten nothing. Okay, eaten nothing. So is 1 minus 6 on 50. Right, 6 on 50. 6 is the eaten nothing. Okay, H dash S dash is 6. 6 is here. Okay, this blue 6 here. Over 50. That's the probability people eat nothing. You know that 6 people eating nothing. Okay, then the other 24 people must be eating something. So it's a 24 over 50 case. It's a 12 over 25. It's a 12 over 25. That's a 24 over 50, 24, sorry. 44 over 50, and then divide by 2 is 22 divided by 25. Is that one? Okay, that's A. B. B is a hamburger and a sausage. That's the probability hamburger intersects sausages. Okay, hamburger intersects sausages. So it's 29. Okay, there's 29 people over 50 people. That's just if you turn into fractions, that turns to fractions, that's 0.88. If you turn that into fraction, 58. C is asking only 1/3 of the food. Okay, 1/3 of the food is 6 plus 9 over 50. There's 9 people only eat sausage. There's 6 people only eat hamburger. So there's 15 people only eat one thing. Okay, from this diagram. So that's a 15 on 50. That's a 0.3. And D is asking hamburger only. So hamburger only, if I use a notation, that's the probability H intersects S dash. Okay, hamburger only is hamburger intersects not sausage. Okay, I don't want sausage, but I want hamburger. So hamburger intersects sausage not. Okay, hamburger intersects sausage not. So that is hamburger intersects sausage not, that's 6 people. So 6 on 50. 0.12. Any questions? No? Okay, can you see this 4 thing here? In this table, this 4 thing here is the elements in Venn diagram. Okay, is the elements in Venn diagram. If you put a Venn diagram here, okay, you have H, you have S. Okay, so the intersection is 29. It's this red 29 here. S intersects H dash, which is 9, which is this here. And H intersects S dash is the 6, which is that here. And the 6 is H dash S dash is this 6, is this 6 here. Okay, this 6 here outside. This 6 is hamburger only. This 9 is sausage only. And this 29 is this number here. Okay, so that is exactly the same as a Venn diagram. Those 4 elements give you the elements in the Venn diagram. Okay. So you have the one, you have the other. Okay, you have one, you have the other as well. Questions? Okay, if there's not much questions, let's continue with the next exercise. The next exercise is easy. Okay, the next exercise is easy. So what next exercise is talking about is only one rule, is the additional rule. Okay, you learned additional rule I think last year. So what is the additional rule? It's when you find probability A union B, it's not only probability A plus probability B. Because, have a look at this diagram. You go probability A, which is this circle here. And you plus probability B is this circle here. Let's say that's area 1, 2, and 3 in the union set. So probability A is the area 1 plus 2. For probability B is the area 2 plus 3. Okay, you have add the 2 twice. Okay, you have add the 2 twice. So what is that 2? The 2 is the intersection. So you add the common part twice. Yeah, it's very makes sense. In A included, in B you included again. So you need to subtract the area 2. Okay, you need to subtract the area 2. So that's why this formula is here. So that's probability A plus probability B and subtract probability A intersects B. Okay, so you plus this 1, 2, plus 2 and 3, and you subtract the 2 once. Okay, that's the formula. So remember this formula. This formula is very important and keep using it until year 12. Mutually exclusive events. Well, year 12 is still talking about mutually exclusive, so better remember it. So what is mutually exclusive? There's no common elements. So then, if there's no common elements, intersection will be 0. Okay, intersection will be 0. Then I can just purely add A and B. I don't need to subtract anything. Because even though I subtract, the subtraction part is a 0. Okay, you can see that's the mutually exclusive events. A plus B is just A union B. Okay, there's no common paths, so I don't need to subtract anything. Okay, so exercising is just as simple as that. Okay, just that. So, let's have a look at example 1. Two events A and B are such that probability A is 0.4, probability B is 0.8, and probability A union B is 0.85. Okay, I want to find A intersects B, and I want to find A dash intersects B dash. Okay, I can find A dash intersects B dash quickly. Remember, A dash intersects B dash is 1 minus probability A union B. Have a think about the diagram. A union B is the two circle, and A dash intersects B dash is the outside area. Okay, outside the two circle. So it's just 1 minus that. Okay, that's the formula. You can treat that as a formula. Okay, probability A dash intersects B dash is 1 minus probability A union B, and that is just 0.15. Okay, 1 minus is 1 minus 0.85, and that's 0.15. Okay, so remember A union B is those two circles here, and here is called A dash intersects B dash. The white area here is A dash intersects B dash. So it's 1 minus the two circles. It's 1 minus union. Okay, now I want to find A intersects B. I want to find A intersects B. Let's just write the formula again here. Probability A union B equals to prob A plus prob B. Subtract prob A intersects B. Okay, that's the formula given above. So A union B is 0.85. Prob A is 0.4. Prob B is 0.8. Subtract prob A intersects B. Okay, you move the prob A intersects B to the left hand side. That's 1.2. Subtract 0.85. So prob A intersects B equals to 0.35, I think. Okay, have a try of example 2 by yourself. Try of example 2 by yourself. Suppose that in a certain school, the probability that students play soccer is 0.18, and the probability students play tennis is 0.25, and the probability that students play both soccer and tennis is 0.11. So what I can have is probability, let's use S to play soccer. The probability of soccer is 0.18. The probability of tennis is 0.25. And the probability that both soccer and tennis is S intersects T, that's 0.11. Find the probability that the students either or both play these sports. Okay, is the probability S union T. Okay, can you see the word here, either or both? That is the typical word to find the union. Okay, the word or is for a union set. Okay, and is for intersection, or is for union. Okay, so that's the key word you're looking for. So what it's asking me is the union. Okay, it's the union. So it's S union T. Okay, S union T. So what I'll have is probability S plus probability T. Subtract probability S intersects T. That's the formula. Okay, A union B is A plus B. Subtract the A intersects B. So S and T is A and B, same. S plus T, subtract the intersection. So I have everything above. 0.8, 0.25 minus 0.11. That is 0.43 minus 0.11. and that is 0.32. 0.32. Okay, if I add a question at the back, what is the probability that students play none of this sports? Okay, what's the probability students play neither of these sports? Like they're playing nothing. Yeah, clear. 0.68. How do you get it? Yep. So what we are looking for is probability S dash intersects T dash. I don't want S and I don't want T. Okay, so it's an intersection case. I don't want S and I don't want T. So it's an intersection case. So as I said in the previous question, A dash intersects B dash is 1 minus the probability S union T. Okay, A union B. So A dash intersects B dash is 1 minus the union case. So that is 1 minus 0.32. That is 0.68. Okay, that's the probability student playing nothing. A student playing nothing. Any questions? Do I have you again tomorrow morning? Okay. Any questions? No? Okay, then if we have class tomorrow, I don't need to go too much. So just finish this exercise up to this exercise. And tomorrow I'll do one more page in the morning for the conditional probability. Okay?